So on a air table, there is a hole in the middle, and then there is a pork. So going around here, okay, and the hole you have a line beneath the table. This object is 5 grams. At the beginning, the R initial is 2 meters, and then the initial velocity, angular velocity is 3, and then you pull this line, and then here the radius change to 1 meter. Okay, and what's the new angular velocity? For this one, what you need to use is the conservation of the moment, angular momentum, right? So you remember L is equal to I times the angular velocity, okay? So we just need to calculate the initial one and then calculate the final one. They should be conserved. The initial one is the initial I times the velocity is equal to the final, okay, and apparently the inertia is the weight, 5 grams is m times r squared, right? M times the initial r squared. The initial angular velocity is 3, right? And the final one, we know the final radius is 1 meter. So the final inertia will be m times final square times the final angular velocity. So until here you understand? And we can cancel the m. And the initial radius is 2. And the final radius is 1. Will be 4 times 3, which is 12. Right? So the answer is 12 for this. Remember, this one is the conservation of angular momentum. It's not the conservation of energy, because you pulled. So you introduced an extra energy to it, because you pulled, you did some work. So remember to use this conservation of angular momentum. Okay, that's this question. For a system, sometimes we need to use this. And the next question, actually the next two is quite similar. Number 18. So on an inclined surface. Okay. Inclined surface. A solid sphere rolls over. Okay. A solid sphere. The radius is r. The mass is m. Rolls without slipping down an incline as shown in the figure. The linear acceleration of a center of mass is what? That's the question. of things we need to get. First, we need to analyze all the force, right? Remember, it's rolling. So there are two kinds of energy. One is the angular energy, because it's moving, the rolling energy. The other is the linear movement, kinetic energy. So there's a gravity. So the force from the surface to support. And then there is a force when it's rolling. You need a force like this to make it rolling, right? So there are these energies. Okay, so we know the acceleration. We draw it again. You along this axis, okay, you have ma, mg, and then F, the force from the surface. This gave it an acceleration of a, right? So what's the component of gravity along this? That will be mg times sine theta, right? Minus this force from the surface will give the sphere an acceleration, right? So the first one you understand? And the second one is a rolling. So it's rolling, and we can get torque is I times the acceleration. And this is the force times